All right, guys. Well, I'm here at school. Many of you may not be today, but I'm doing a quick lesson. One quick update as you're watching this. Our test. I'll probably post this anyway, but our test is going to be on Monday instead of being on Friday, which is what I originally had planned. So anyway, I still want to try to kind of keep moving forward. Don't make today a complete waste. I'm going to cover geometric series. You can see the notes right here. So I'm going to go over that. I'll do that now, and again, this will be due basically for tomorrow. So make sure, obviously, you get this finished today, and we'll get going. All right. So first off, a geometric series, as I'm sure you know, a series is where you're finding the sum of the terms of a sequence. So a geometric series, you're finding the sum of a geometric sequence. So that summation formula is going to look like this: is S sub n equals a sub 1 times 1 minus r to the nth power. That doesn't look very good, so I'll fix that. 1 minus r to the nth power divided by 1 minus r. And this is when n is the number of terms. A sub 1 is going to be your first term. And r is going to be your common ratio, or your rate. All right. So on this, there are three different scenarios that you will need to find the sum of. So we're going to go over those three scenarios now. I'm going to pick, I'll pick numbers 2, number 4, and we'll do let's do number 8. All right, so those are the three examples that I'm going to go over with you first. So the first one we're going to get, again, we're finding the indicated sum of each series. First one's pretty straightforward. Everything's really just being given to you. You're given a list. I'm telling you which, how many terms we want to find the sum of. So we just plug this in. So again, to plug it in, we need to know the first term. And we need to know your rate. If you're not sure how to find the rate, here's how you can always find it. Take any two terms, it doesn't matter which two, so I'll pick the smaller ones instead of the bigger ones, and divide the second term by the first term, and you get 1/3. And you can kind of see, yeah, if I multiplied by 1/3, I would go from 9 to 3. It does match. So your rate is 1/3, and then obviously n is 20, because we're finding S sub 20. Okay, so S sub 20, here we go. We're just going to go a sub 1, which is 81, times 1 minus r to the n, so 1 minus 1/3, to the nth power, which is 20. And that's all over 1 minus r, so 1 minus 1/3. All right, so here you probably need a calculator. On a lot of these are going to be kind of big and crazy. So I'm going to go ahead and do that now. Usually what I'll do is I'll try to do this in parts. So I'm going to go 1 minus, and I'm going to go 1/3 in parentheses to the 20th power. So I'm just doing that piece first. I'm going to multiply that number by 81. So that's my numerator. I'm doing this all in the calculator because the numbers can be kind of crazy sometimes. So that's my numerator. I'm going to divide that by 1 minus 1/3. You can just say 2/3 because that's what that is. But otherwise, make sure you're doing the fractions in parentheses here. And 1 minus 1/3, you get 121.5. And there's your partial sum. That's S sub 20. And again, those are the pretty much straightforward ones. You just plug into the formula and you're good. So that's number 2, and that's what all the basic ones are going to look like. And then we're going to move on to number 4. So number 4, you're missing some stuff. You're given a sub 1, which is 4. You can find your rate. You could just, again, pick any two terms. So if you don't know what the rate is, take any two terms. It doesn't matter which two. I'm going to say negative 12 over 4 is negative 3. so your rate is -3. So you have a sub 1 and you have your rate. But what you don't have in this case is n. You have the last term in that series of numbers, but we don't know what term number that is. So in order to figure out what n is, so again, to find n, we are going to use the explicit form. So the explicit form, a quick reminder, is going to be a sub n equals a sub 1 times r to the n minus 1. So if I have my rate and I have the first term, again, I have these two numbers and I have a sub n, it's 2916, or yeah, 2916. Notice I can plug those three values in and solve for n, which is what we need. So I'm going to use the explicit form on this to find my n value. So I'm going to go 2916 equals a sub 1, which is 4, times r, which is -3, to the n minus 1. Okay, so now we have to solve for n. So I'm going to zoom in here a little bit. I'm going to divide by 4. And again, we'll have the flip that up. I'll have the calculator out as I'm doing this as well. So 2916 divided by 4 is going to be 729. And before I do this next step here, let me stop moving the screen as I write, we're going to have a slight issue because the next step involves us taking the log of both sides. But when you take the log, if I'm doing natural log, if I take the natural log of -3, again, a log can't be negative. It's not going to work. So we have to find some way to work around that issue, and here's how we're going to do it. Okay, these numbers, you have a rate of -3. So these numbers, the signs switch every time. However, you're still multiplying the number itself by 3. I'm not too concerned with the signs at this point. I'm concerned in when I multiply by 3, when am I going to get to 2,916? So what that means is I can just call this rate 3 and figure out when I get to 2,916. And that way we don't have to worry about that negative. Our natural log won't give me an error. So that's our workaround for that. If you have a negative, just make it positive. The number is still being multiplied by 3. The signs, again, in this case, don't really matter. So we're just going to natural log both sides. And I'm going to go ahead and use that power rule, pull down that n minus 1. So now I get natural log 729 over natural log 3. Let's go ahead and do that. So natural log 729 divided by natural log of 3 is 6, which is great. So I'm running out of room here. I'll move it over to the side. So n minus 1 equals 6, so n equals 7. So there we go. All right. So again, at this point, we're able to now find the partial sum, because that's really the whole reason I was doing this, is to find a partial sum. So let's find it. So I'm just going to go and use this little corner right down here. So I'm going to go s of 7 now. I now know it's s of 7, which equals a sub 1, which is 4, times 1 minus r to the n, so 1 minus -3 to the nth power, all over 1 minus r, so 1 minus -3. And just plug it in and see what we get. Okay. I don't know why I said n, though, for this thing. We know what n is. N is 7. My apologies on that. We're good. All right. So I'm going to go, I'll do the 4 later. So let's go 1 minus, and then in parentheses, -3 to the 7th power. So I'll start there. I'm going to take that number, multiply it by 4. And actually, I'm going to end up dividing that number by 4 as well. As you can see, 1 minus -3 is 1 plus 3. So divided by 4 would be back where we started there with that 2188. So we're going to get 2188 for that sum. So there's your partial sum. That's probably one of the harder ones. Although, again, the sigma notation is what drives people nuts, but that one's not so bad either. You just got to know how to use the explicit form. You got to use two forms to get to where we want to be. Okay, so that's going to be the second scenario that you're going to see, so make sure you're kind of studying and preparing for each scenario, because you'll probably see most, if not all of them. And you know you're going to see a bunch of sigma notations, so let's do our sigma notation. So remember, we're doing a partial sum yet again. Reminder, this is your explicit form of your sequence. So a sub 1, again, if you're plugging this in, all you got to do to find a sub 1, in this case, is take this number and plug it in for m. So, because we're starting m equals 2. So I'm going to go 81 times 1/2 to the 2 minus 1. So basically it's 81, in this case, times 1/2. So that's all you're doing. So it's going to be 40.5 for a sub 1. Okay, so that's your first term. I need my rate. My rate is right here. I don't need to do anything to find it. Remember, this is your it's like a times b to the x, where b is your rate of change. So it's 1/2. It's just coming from your exponential function. So 1/2 is your rate. And in, remember, we always do 11 minus 2 plus 1. We have to put in that plus 1 to get our proper number of terms. So that's going to be 11 minus 2 is 9. 9 plus 1 is 10. So n is 10. So now you have everything. So these tend to be ones that get people, but it's actually less work than the one we just did. Everything's given to you. You just have to kind of go find it kind of yourself a little bit. But here we go. Let's do this. We have trying to do the partial sum, so I'm doing s sub 10. So that equals a sub 1, which is 40.5, times, in this case, 1 minus r to the n, so 1 minus 1/2 to the 10th power. And that's all over 1 minus r, so 1 minus 1/2, which is 1/2, by the way. So calculator time. So I'm going to go 1 minus 0.5 in parentheses to the 10th power. I'm going to multiply that number by 40.5, and that's my numerator. So you get your numerator. I'm going to divide that numerator by basically 1 minus 1/2, which is 1/2. So I'm going to divide by 0.5 on my calculator. And there we go. I'm going to get about 80.92. And that is your partial sum. So those are, again, partial sums of geometric series. We will work on infinite, as you can see, geometric series. That's really one of the last things we have to cover before the test. We'll work on that on Thursday. So go ahead and at this point, again, I'm not assigning any homework for this since I am finishing the unit. If you are done with everything, then you can start this assignment. Anything that has you find a partial sum, you are able to do. But if you need to find an infinite sum of a series, we'll cover that on Thursday, and then you'll get that last assignment for it then. All right, so good luck, and I'll see you guys hopefully in a couple days.